Okay, so good evening and welcome back to another class for Java programming. So, just like the previous class, today we are again going to discuss about sorting. So, today we'll look into the details of selection sort, and we'll also take a look at the um, programming code for selection sorting. So, let us first do a quick revision of what, or rather, how selection sort exactly works. So let's take an example of an array and just quickly, do something similar to a dry run as to how selection sorting works in an array. So let's say this is our array on which we are going to perform selection sort. So as you know, we can either sort. So let's say this is a number array or an integer array called n. And let's say there are certain numbers such as 10, 5, -2 and 7. Let's say we are just for the time being working with just four numbers. So this is a number array. Now since we are sorting, we'll want to sort in a specific order. Let's say we want to sort this array in ascending order. So by ascending order we mean that the smallest we will sort in such a way such that the first location of the array has the smallest number and the last location of the array has the greatest number. So we'll arrange it in a way such that it goes from the smallest and one by one it increases until it reaches the greatest number. So we're going to sort this in ascending order. So we are doing the example by showing you to sort in ascending order, but while writing the program we'll take a look at both the orders. We'll take a look at the ascending order as well as descending order. So as the name suggests, selection suggests, we select a position of the array, which is basically the starting position in the array. So we select that position, and what we do is we start comparing with the other elements that are there in the array. So we select 10 and we compare it with the very next element in the array. Since we are arranging in ascending order, so if the present element is larger than the element to which it is being compared, we'll do a swap. We'll just interchange the values. So in this particular case, as we can see, 10 is greater than 5. So what we have to do is we have to interchange their positions. So what happens is, in place of 10, we now have, after swapping, we have 5 here, and 10 goes to the place where 5 was there initially. So after the first comparison we have something like this. So this is the result after the first comparison. Now what we do is we compare 5 with -2. So 5 is the present or the current value after the first comparison at the first location of the array. Now we compare this value at the first location with the, so this is done. We have finished comparing with this value. There was an interchange that happened. Now we compare 5 with the next value in the array, or rather the value at the next location in the array. So 5 compared with -2, again we see that 5 is greater than -2. Since we are arranging in ascending order, we'll again need to swap the values because -2 is smaller than 5. So it will come in place of 5. So minus 2 comes now in place of 5, and 5 takes the original position of minus 2. So we have finished comparing with this position or with this element as well. So now we'll move on to the next element. So now the present value of the first location in the array after the interchange is now minus 2. Minus 2 is now compared with 7. Now in comparing minus 2 with 7, we see that minus 2 is less than 7. So basically there will be no swapping because minus 2 is already less than 7. So it's already in its correct position. So therefore there is no swapping in this case. Thus we have now come to the end of the first iteration. So this was the first iteration. Let's call this the first iteration, which basically um, finds out the correct value that needs to be there at the first location of the array. So the number of iterations will be as per the size of the array. So if the array has let's say 4 values, so it will be technically it should be one less because when we have already arranged up till this particular value, so the last value will already be sorted on its own. So I think there seems to be an issue with the stream. Just let me check once and we'll get back to the class. So I guess the buffering problem is more or less eliminated now. So let's continue with the class now. Okay, so as I was telling you, minus 2 is compared with 7 and we see that minus 2 is less than 7. So there is no interchange that occurs in this particular comparison. So what happens is now we have completed comparing. So we have finished comparing with all the elements in the array and we have the element at the first position sorted. So basically as I'm calling this the first iteration, you might guess that the number of iterations will or rather should be equal to the number of elements that are there in the array or the size of the array. So logically, yes, logically speaking, it should be. So the number of iterations that I am going to do to get the sorted array would be equal to the should be equal to the number of elements in the array, the total number of elements, but it will be one less than the size or one less than the number of elements because once we finish sorting up till this position, the last element is already sorted in the array. So there's no point in again comparing it and sorting it again. So running that iteration is basically pointless. So once the array is sorted up till the second last position, the last position in the array is automatically in a sorted position, right? So there's no need to be comparing it again to any anything else. So that is why it runs one less than the size of the array. So my point is that the total number of iterations that will be there for sorting this particular array will be one less than the total number of elements in the array. So the total number of iterations that we'll have here is 3. So this was the first iteration after which the first element in the array was sorted. Now we'll move on to the second iteration. We again have the updated array as follows. So now we have -2 here, 10 at this position, 5 here and 7 here. So the final status of the array after the first iteration is the so we begin with, so the second iteration begins with the final position of the elements at the end of the first iteration. So at the end of the first iteration we had these particular positions after rearrangements. So that is where the second iteration begins, with that same particular arrangement after the first iteration. So now we have these elements at these particular positions. So if you remember the original array, let me write down the original array here. So the original array basically had the elements in these particular positions initially. So let's say this is the original array that is unsorted. So 10 was at the beginning, 5, then there was 5, then there was -2 and 7. So these were the original position. These were the original positions of the elements in the array. Now, after the first iteration, the original position has been altered a bit, and we have this particular positions of the elements after the first iteration is completed. So this particular part of the array is sorted. So since the first element in the array is sorted after the first iteration, this particular part is sorted and this particular part remains to be sorted. So this has to be sorted now. So in the second iteration, we again start with the second position in the array. So we select that position. Now we repeat the steps that we did previously. We take the value at this position, we compare it with the next value. We find that 10 is less than 5. So we again have to swap the values. So now 5 comes in place of 10 at position 1 and 10 comes in place of 5 at position 2. So 1 and 2, the positions 1 and 2 are the index numbers respectively. So after interchange, now I have finished comparing with this element and they have been rearranged as per their correct positions. Now we are going to compare 5 with 7. Now what happens when we compare 5 with 7? We see that 5 is less than 7, so there is no interchange that happens here in this particular step. So we have finished comparing with this and our second iteration comes to an end. So now we have the array sorted up till the second position. So the array now is sorted up till this particular position. So this part is sorted. This particular part is sorted. So let me write it down neatly. So now this particular part of the array is sorted and this remains to be sorted. So this is unsorted. So this is unsorted and this part is sorted after the second iteration. So as you can see, after each iteration, so the iteration number corresponds to the location or the position or the number of elements rather which are sorted after completing that iteration. So after completing the second iteration, two elements, the first two elements in the array is sorted. So now let's move on to the third iteration. So this will be the last iteration, as I told you, since the number of elements in the array is 4. So there will in total be 3 iterations to sort the whole array. Now again, as you can see, we will start with the current locations of these elements at the end of the second iteration. So now we have the array like this, and we have -2, 5, 10 and 7 respectively at these positions in the array. Okay, and as we had seen previously, the array is sorted up till this mark. So this portion is already sorted, and this portion we will be sorting them now. So now, since this is the third iteration, which means we will be selecting the third position in the array. So after selecting the third position, what we do is we compare the value with the next value in the array. We see that 10 is greater than 7, which means we need to swap the elements. So 7 comes in place of 10 and 10 takes the place of 7. Now there are no other elements after this, so we have exhausted the array, and as you can see, the third iteration comes to an end here because we have no more elements to compare to. So the third iteration ends at this particular time, and what happens is the array is now sorted up till the third position or index number 2. So the array is now sorted up till this position, right? So after completing the third iteration, now this part is sorted, and this is automatically in its correct position since we have no more elements to compare it with. So the last element automatically after the second last iteration is automatically in a sorted position. So now we have the whole array sorted. So this was the original array, and the sorted array or the array sorted in ascending order is as follows. So after the third iteration, the array that we are getting -2, 5, 7 and 10. So as you can see, the elements are sorted in ascending order, starting from the smallest and going to the largest. So that is how selection sort basically works. It's pretty easy. You just select a position and keep on comparing it with the values at all the other positions. If you find an order mismatch, you just swap the values, and if everything is fine, you just move on. You keep on moving or traversing the array until you reach the end of the array. So there's one point that we learned here, and that's a point that we need to remember is, so points to remember, the or rather points that we have seen up till now. So points to remember in case of selection sort. So point 1, number of iterations. So this is just a logical point. So number of iterations is less than size of array. So I'm not writing. So I'm writing with respect to programming notation. So if I write less than equal to, which means it is equal to the size of the array. And since I'm writing less than the size of the array, which means the number of comparisons will be one less. So let's just write the whole thing is, so as to not confuse it, just let us write the whole thing. Number of iterations is 1 less than the number of elements in the array. So that's the first point that we need to remember. The number of iterations for selection sorting is one less than the number of elements in the array. Second point, what is the second point that we need to remember? So in selection sort, a particular position. So people often confuse, since selection means that something is being selected, so people often confuse with whether the element is being selected or the position. So it's basically, technically it's the position that is being selected and held, and then the value at that position is being compared to the other values at different positions. So a particular position is selected and compared to the next positions after it. So it's never compared to a position before the element that is being, so before, so let's say this position, the first position is selected, so it's never compared to a position that comes before the selected position. It's always compared to positions that come after the selected position. So that is what is meant by the second point. So a particular position is selected and compared to the next positions after it, not before it. So the elements before are not compared against, only the elements after the selected position are compared to. So these are two important points with respect to the logic of how selection sort works. Remember these 2 points, it will help you to write the program. So let's take a look at the programming code of selection sort, and these two particular points that I have mentioned here, those will be much more clearer once we write down the program. So let's take a look at the program now. So we will be using class designing to write the program. So we will follow the um, process which we have been following for so long in this class, to write a program. So we'll design a class and then create objects to call methods inside the class. So now let us begin with the programming code. So as usual, we will have a class, but before that, since we will be entering the elements of the array from the user, so we will have to import the scanner class. So we will have an import statement. So import, so let me just start from the beginning of the code. So import java.util.scanner. This beginning part of the program is pretty basic. Next we have the class keyword and the class name. Let's call the class selection sort. We have the opening braces of the class. Inside we'll define an array. Let's say we want to work with an array of size 10. So we will define an array of size 10. Later on in the future classes, I'll tell you how to take the array size as an input from the user and then define the array using the user defined size. So let us just work with a predefined size. So we'll work with 10 elements. So int, let's call the array n as usual, is equal to new int and we are working with 10 elements. So we are not going to write a constructor. We will be writing constructors once we do, once we study constructors in more detail in future classes. So now we are just leaving it up to the default constructor in the that's provided by the compiler. So we are not writing a user-defined constructor. We'll directly go to the functions. So the first function that we are going to need for this program is the function to take input for the elements, or rather feed the array with elements. So just like our previous searching program, we'll have the same function, which is a void function called feed array. This will basically feed elements into the array. So feed underscore array. In this particular function, we will just first we have to define the scanner class, since we will be taking input here. So scanner SCZ. So it's basically the same function that we had written while we were studying the linear searching method. So it's pretty much the same code, and I'll have an SOPLN statement here asking the user to enter 10 numbers, and I'll have a for loop to take input for those numbers. So for int I, so I'll start with 0. It's pretty much the same thing. I is less than 10, I plus plus, and n of I is equal to sc dot next int. So up till now we have all been we have been using the scanner class through and through whenever we are writing any programs. So when we discuss about string library functions in the future, we will be learning about the buffered reader class, since there are certain methods of the buffered reader class that you need to learn. So we will be doing the string programs using the buffered reader class. So before that, we'll be just using the same old you know code. So this is basically taking inputs, and that's the end of the void feed array method. So that's pretty much the same feed array method that we used in linear search. So I hope you have finished copying it down up till here. So I'll be rubbing this whole thing off, and we will move on to the next function, which is to display the display the elements in the array. So let me rub this off. And let us now write the display method. So again, the display method is the same as that of the linear search program. So it will be void display. It does not take any parameters. Inside the display method, we'll have a for loop to traverse the array and print the values at the locations in the array. So we'll just have SOP, not SOPLN. Always remember this. It will be SOP, since we want to print the elements in a horizontal line, not one after the other at every new line. So we will have SOP n of I plus a space, so that there's some space in between the elements when they are being displayed, and that's our void display method. So basically displays the elements in the array. Now we come to the function that is actually, the main function of this program. So we are going to write down the sorting function, which will sort the array in ascending order. So first let us write down the function that sorts the array in ascending order, and then we'll also write another function similar to the function that we are going to write now, which will sort the array in descending order on being called. So let us call this particular function void um, sort ascending. Since we are sorting using this function to sort it in ascending order, so void sort ascending. Inside we are going to do something. So at the beginning of the class we had taken a look at how selection sort works. So we're going to employ that particular logic itself in this particular function. So as I told you, there were a number of iterations where we were selecting a position and then comparing. So the iteration where we were selecting a position will need a loop. So we'll be using a for loop for that particular iteration where we were selecting a particular position of the array. So for inti, so it will basically always start with the first position of the array. If you remember, I told you 2 points to remember for selection sort. So the first point was the number of iterations would be one less than the number of elements. So I is less than. So what will come here? What do you think will be the value here? So this is as usual I plus plus. So this particular value is very important. Um, if you put a wrong value there, you'll get wrong outputs. You might get a half sorted array, or you might get an error where it says something. So you might get an error where it says that the array index is out of bounds. So that's so you might get something like this array. This is a type of an runtime error. So array index out of bounds. This is an error that you might get if you mess up the value here in the for loop. So array index out of bounds basically means that you are trying to access an element that does not exist in your current array. So you're trying to access an index that is outside of your array. So that is what that error basically means, array index out of bounds. So if I write here, so if I write 10 here, so if I write the value 10 here, I'll get this particular error, array index out of bounds, because I told you when the array is sorted up till the second last position, the whole array is sorted automatically. So instead of 10, I'll have 1 less than the size of the array, 9. So I is less than 9. Since the size of the array is 10, I'll have 1, the value will be 1 less than the size of the array. So the number of iterations, so this particular loop controls the number of iterations, number of iterations. So this particular loop controls the number of iterations. And as I told you, the first point that you had to remember is the number of iterations will be 1 less than the size of the array. So since the size of the array is 10, the number of iterations is 1 less than the size of the array. So I runs from 0 up till 9 or less than 9. So 0 to 8. And in each iteration we were comparing the selected position with all the other positions after it. If you remember correctly, then we were selecting a particular position in the array, and then we were comparing that particular position to every other position that comes after that selected position. So again, for those repeated comparisons, we'll have another for loop, another looping statement. So I'll be using a for loop. So let's call this loop variable j. Now remember, j always starts, so we were selecting one element here in this particular, so in an iteration we were selecting an element that is done by this particular for loop. So we are selecting an element using this for loop. Now to compare it, we are going to compare it with the very next element after the selected element. So logically speaking, j is beginning from I plus 1 always. So if I is the first element at the 0th index, j will be the element just after the 0th index, which is at the 1th index, and these two elements are compared. These two element values at these two particular positions are compared. So it starts with I plus 1. That's the reason why it starts from I plus 1 always. So basically, if you take a look at the array, so this is an array. So there are certain values. So let's say 5, 7, 9, etc. So this is the 0, 1 second position. So if the for loop starts from this particular position, it selects this position and it compares it with the very next element. So this comparison is being controlled by this particular for loop. So this particular thing will always start from uh, a position that is one ahead of the selected position. So it will always start with the next position. So when this element is selected or this position is selected, the second for loop starts at this position, that is one ahead of the first position. Again, when this particular element is this particular position is selected, so it again the comparison starts from here. So this is compared to this, so it starts with one ahead. So that's the reason why it's I plus 1. Instead of just starting with 0, it's I plus 1. So now j starts from I plus 1. J will always run up till the array is exhausted. So j is less than 10, because we are going to compare it with all the elements in the array. So it runs up till the array is exhausted. So it basically runs for the whole array, for whole size of the array, and j plus plus as usual. Next we compare. So now we compare, the actual comparison happens here. So this loop uh, controls the number of iterations, and this particular loop controls the number of comparisons. So let me write down the full thing. Controls, so it controls the number of comparisons, and the first loop controls the number of iterations. So controls the number of iterations. So I hope that those two parts are clear. So the first loop controls the number of iterations, and the second loop controls the number of comparisons that are going to happen. Now let's do the actual comparison. So to compare two elements, we will be using the if statement. So if n of I, since we are sorting in ascending order, so if n of I is greater than n of j, which means the previous element is greater than the next element, we do a swap. So this particular line means that the previous element, which is n of I, is greater than the next element. So if this is true, we have to swap the elements. So what we do is we interchange them. So we make use of a temporary variable So make use of a temporary third variable for doing the swapping. So temp, we set temp to n of I, just like we have studied, just like you have done swapping of elements, it's pretty much the same thing. So n of j is equal to n of I, and n of I is equal to temp, and that should be the end of these two fors. And also, so before we end the function, we have one more thing to do, but just to be clear, this particular loop again controls the number of iterations. This particular loop controls the number of comparisons in each iteration, number of comparisons. So here we are actually comparing the elements. So we are comparing the position, look, value at the ith position to the value at the jth position, and j is nothing but the next position after I, and it keeps on increasing. So j represents all the positions after the ith position. So we compare n of I to all the positions after the ith position. So this comparison happens here whenever we find that the ith position is greater than the uh, next positions that come after it. We just do a swapping. So we swap the elements. Since we are arranging in ascending order, the smaller element must come before. So we are doing this swapping. So here we are comparing, and here we are basically swapping. Okay, so here in this if statement we are comparing, and here inside the if statement, if this is true, we are swapping the elements. Now this is the end of the inner for loop. So end of nested for, and this is the end of the outer for loop. And before we end the before we finish, end the whole function, so before ending the function brackets, we have to do one more thing. So I'm rubbing this off. So before we end the function, we just make a quick call to the display method, so that it happens automatically. So let's say we don't know, we want it to sort as well as display as well. So what we do is we make a quick call to the display method here, just before ending the void sort ascending function. We make a quick call to display. Since it is a void function, you can just make a call directly like this. Since we are inside the class, we do not need an object. We can directly call the display method from any other methods that have been, you know but the main function is a different thing. So okay, let's not confuse it with object call and non-object call. So let's just end the void sort ascending function here. So I hope you have copied down the void sort ascending function. So for the void sort descending function, so we'll have on one more function to sort the array in descending order. So void, let's call it sort descending, just like we call the previous one sort ascending. So let's call this sort descending. It does not take any arguments. It's pretty much the same program code, except there'll be a slight change in the if statement. So it's pretty much the same code that was there in void sort ascending method. So I is equal to 0, I is less than 9, I plus plus. Just a simple change will you know sort it in descending order instead. So int j is equal to I plus 1, j is less than 10, j plus plus. So this is the same as that of the previous method. Now here comes the change. If n of I, so we were doing greater than n of j, Instead of that, when we are arranging in descending order, we'll do the opposite. We'll do n of I is less than n of j, then we swap. So previously, when we were arranging in ascending order, if the previous element was greater than the next element, then we were swapping. But when we are sorting in descending order, if the previous element is smaller than the next element, at that time we are swapping. So again, the same thing, int temp is equal to n of I. Now n of I is equal to n of j, n of j is equal to temp. So we are swapping here and the method ends here. So the sort as so if you can write down the sort ascending function, the sort descending function is pretty easy. You just need to change this particular sign. So this particular sign makes all the difference. So if it is greater than n of I is greater than n of j, then it is sorting in descending. It is sorting in ascending order. And if it is less than n of j, it is sorting in descending order. So that's the only change that happens. Sorting in ascending or sorting in descending. So again, points to remember. So you can very easily remember these two methods. So just remember one method and you will remember the other automatically. So for ascending order, we'll have if n of I is greater than n of j, swap. Okay. For descending order, so for descending order, we have if n of I is less than n of j, do a swap. Remember these 2 points, and the rest of the thing is common for both the functions. So the only difference lies in the if statement. So if n of I is greater than n of j and we are swapping, which means we are arranging in ascending order. And if n of I is less than n of j and we are swapping, it means that we are sorting in descending order. So it's pretty simple. So we have finished all the functions that we want to write in the class. Now we will move on to the main function. So we'll be writing the main function inside the same class itself. So this is the main function, pretty much the same header as always. So public static void main, string args. Okay, inside the main function we are not going to have any inputs, so we'll just define an object. So the class was called selection sort, if you remember. I'm calling the object obj is equal to new, and we are calling the default constructor here. Now that we have an object, we will call the methods in the class using this object. So the first function that we are going to call is feed array, obviously, because we need elements before we are going to sort. So we call feed array. Once we have called feed array, we now have elements in our array. So once feed array is executed, we now have elements inside our array that was defined in the class itself. So before sorting, we just print the original order of the elements. So we just print a message before sorting, and we call the display method obj.display. This will display the array. So before sorting, we display the array. Now after sorting, we will again have to display the array. So now we write after sorting. Okay. We also add, since we are going to sort in both ascending as well as descending order, we'll again add one more message to the user. So sopln, or rather let us first call the sorting method. So obj dot, so it was the method called sort underscore ascending. So we are first sorting it in ascending order. Now once we have made a call to this particular function, the array is automatically sorted in ascending order after this function is executed. So we display sopln ascending order, and we call the display method to display the elements in the array. So all these operations are happening on one single array. So the array that we had defined at the beginning, so we're feeding elements into that same particular array. We're displaying that array before we are sorting or calling the sorting methods. So next we are calling the sort ascending method. So that same particular array is being sorted in ascending order. We are again displaying that sorted array. Okay. Now we are going to call, rather let's print the message. So we are going to call the descending function, so sort descending function, to sort it in a descending order. So descending order, we call the sort descending function sort descending, and to display the array we again call the, so after sorting, to display the array we again call the display method. That's the end of our main function, and this is the end of our class. So inside the main function, we feed the array, we display the array before sorting, we sort the arrays in ascending order, we display the array that has been sorted in ascending order, we again sort the same array in descending order, and we display the sorted array which has been sorted in descending order. So that's the whole program of selection sort. It's it's more or less easy once you understand how it works. So if you understand the for loops inside the sorting functions, how are they working, it's pretty much easy to write the program on your own. And there are two things that you have to remember: how each for loop works, what is the job of each for loop. As you can remember, the first for loop controls the number of iterations, and the second for loop controls the number of comparisons. And the next thing that you have to remember is, inside the for loop, the if statement will determine whether it is being arranged in ascending order or whether it's being arranged in descending order. So depending on the less than or greater than sign, it will either be arranged in ascending or in descending order respectively. So that's the complete selection sort. I hope you have pretty much understood what selection sort is and how it works. Also, before we end today's class, I don't remember. Probably I had, given a vague definition of what actually sorting is, but the actual, definition, if they ask you in a question, what is sorting? So, sorting basically, the definition of sorting is, so if they ask you the question, what is sorting? The answer is pretty simple. Arranging in a given order. So, what is sorting? It's pretty much arranging in a given order. So that's the shortest definition that could be there for sorting, arranging in a given order. So you could just expand on that depending on the question that you get. You could either say arranging elements in a given order or arranging objects in a given order, whatever it may be. It's pretty much basically arranging something in a given order. So that's the definition of sorting. And with that, we shall end our class today. So in the next class, I would want you to go through the whole selection sort and linear search classes. So you go through the previous class, the class that was before that, as well as today's class. If you have any doubts, let me know. We'll be discussing those doubts in the next class. And the topic for the next class is bubble sorting. So this is another method of sorting. So this is the topic for next class. So in the next class, we'll be learning about bubble sorting. So thank you for joining today's class, and make sure to revise everything that has been done up till today, starting from searching up till selection sort, and do let me know if you have any doubts.